I only have 45 minutes, so this won't be any general introduction towards the concepts of Lagom or everything inside of Lagom. If you actually want to have more information, I think you should read the documentation or ask the guy in the green sweater there, because he knows everything about Lagom, right? But basically what I wanted to do here is to look at one of the concepts from an architectural perspective, and that's events first microservices. So first off, I work at Cibia. It's a software consultancy firm, not only in the Netherlands, but also in France, in India, and also in the US. And in our consultancy day-to-day jobs, we do things like agile transitions, infrastructure help, but also consultancy from a software development perspective. And doing that, I mean, microservices is hip. Was hip and trendy even 4 years ago. So actually we did a lot of implementations. And I think most of us actually have the same feeling, is that at some point people said, well, if you will do microservices, then everything will be okay. You currently have a problem with your monolith. The only reason why you're having problems scaling this thing is because you're not doing microservices. And as many opinions there are about microservices, I think there are also that many mixed results in actually the implementations we did in microservice architectures inside of Cibia. And I think one of the main reasons for that is that if people pitch the idea of microservices, and this is by the way an image from the Reactive Manifesto, because I think they align quite well, is that most of the people just focus on the upper half. So they wanted to have a system which was more performant than the system they currently had. They want to have a system which was more elastic, more scalable, and potentially even more resilient, because it's one big monolith. If something breaks, then everything goes down. And if you just implement microservices, well, everything will be okay. But they stop forgetting, I think, the most important part in microservices is the message-driven part. I think the first implementation of the Reactive Manifesto, they didn't have the arrows, and they didn't have the words next to it. But if you can still see it, message-driven development or message-driven architecture basically drive all the other traits you have there. So if you actually want to have a system which is resilient, responsive, and elastic, it's actually quite hard to do that without any message-driven architecture driving it. And looking into our journey of microservices was a bit of a rabbit hole. I mean, if you look at most of the blog posts on microservices, it started off, okay, what kind of infrastructure do you need? Do you have to go completely cloud native? Do you have to use Spring Boot or whatever? Then a lot of discussions about what is the optimal size, some kind of formula you could calculate, and you put the input factor, how many functionality you want to have in a service, or in your application, and the outcome was, okay, then your microservice should be this long. Also saw lines of code as some kind of measurement in terms of splitting your microservices. If it reaches more than 3,000 or 4,000 lines of code, then it should be split or whatever. And for me, actually, this gave the feeling that instead of complementing the problems we have with the idea of microservices, that basically we were trying to force our problem into that. Just maybe to take a step back, what is actually the thing we try to solve? And when we look at the history of software development, we always start with, well, maybe a small system, small team that gets bigger and bigger. And at some point, our team gets bigger, and we hope to actually have the same level of performance for each developer working on the same system. And one of the more important parts there is to have a modular system, because if you're all working on the same thing, it's actually quite hard. If I change a line of code and you change the same line of code and somebody else does it at the same time and trying to merge that, will be quite difficult. So we hoped, well, potentially we can do it with modules, and we all know if you have a logical boundary, somebody has a deadline, and instead of 4 weeks, it has to do in 2 nights, then eventually modularity just, well, will be killed in sake of just getting functionality online. And I think microservices helps here because having an async boundary instead of a logical boundary makes it far, far more difficult to actually ruin somebody else's work. But those boundaries are very important. And at some point, maybe you say, okay, I will split my application into 2 services. That thing will send commands, and we hope that we have our boundaries right. If you split up an application in services, then not automatically you have your modularity right or you have your autonomy right. So what happens normally if service A has some kind of behavior, sends a command to service B, and service B goes down, that means that we'll immediately have a problem in service A. Maybe you should implement a retryer or whatever. And what you see there is that even if you have those services, you have the level of modularity, cascading failures are actually quite difficult. So we not only need boundaries in our system, but we also need a architectural pattern which will enable autonomy within and over those boundaries. And I think then where we normally reach domain-driven design. I think everybody's familiar with domain-driven design at some point. I'm actually quite surprised that people are implementing microservices without knowing what domain-driven design is. It's actually, a lot of times I see this, and then they said, okay, we failed microservices failed us. It's not our problem, it's the architectural pattern. And then you start asking questions, where would you start slicing, or how was your system composed? And then you get indeed lines of code back, or somebody just made a service and then it just started to exist. And everything is dependent on that service. If it goes down, then we have problems. But if you look back towards the theory behind domain-driven design, in that blue book everybody pretends to have read, but I guess most of the people actually didn't make it past chapter 4 or 5, is that it describes a way of splitting or structuring business processes into domains and aligning those with technology. By the way, if you have any questions, we're a small crowd, so you can just ask along the way. And I think one of the important parts here within domain-driven design is the concept of bounded contexts. If you will map them somewhere, this potentially could be comparable towards a domain, but I think the word bounded context actually describes something better, is that you have an explicit boundary, not only for language, but also for complexity of logic. And this could be very helpful if you develop services. If you want to have something completely autonomous, that means that you have to have some kind of boundaries to ensure that that service can just do its work without any other service. And I mean, the initial implementations, if you see, okay, the book is quite old. We didn't have microservices at that point. So if you talk with people about domain-driven design, most people start talking about domain objects. Say, okay, I have some kind of folder structure, I have some kind of package structure in my Java application, and then I have a package called models, or domain, and then I just add some kind of domain models there, and then I'm doing domain-driven design, because I separated them into packages. The problem is that you tend to think that the strength of domain-driven design is structure. But if you think structure first, the problem is that, well, architects and designers like to actually make very large upfront decisions. So also discussions with more traditional IT organizations, and they say, well, we implemented domain-driven design, we have two architects, we just draw out all of the domains, and then we build services, and then everything went wrong. And that's the problem, is that, well, the problem normally is that structure weighs you down. Because if you have something visualized in your head, it's actually quite difficult to unvisualize it. So if somebody made a pretty picture and said, these are the domains, this is the way our organization works, it's actually quite difficult to step away from that and think of something new. Russ Miles once stated that it's not the things that matter in the early stages of design, it's the things that happen. And I'm quoting Russ Miles here because Russ Miles is a bit sad by the fact that the complete idea of event-driven microservices came from him, but nobody's crediting him, so I'm doing it now. But if you look at the things that happen and you reverse, do a reverse dictionary search on that, then eventually you'll get back this word. Not completely coincidence. So if you look at what an organization, what normally happens within an organization is there's just a sequence of events. Somebody will say, okay, I will place an order, and that order is handled, and then eventually that order is paid, and then eventually that order will be shipped. That's your business process. There's no structure in that. There's nobody saying, okay, where's my domain object? If you will talk with your stakeholders, nobody will ask, where's the database record? He just wants to know, or he or she wants to know, how the business process is working. And I think that is what events is complementing in domain-driven design, is that you can actually do something else, or something differently, instead of like focusing on the domain objects, focusing on the structure, is that you actually do domain-driven design in which you think about the events first. So what are the relationships between kind of bounded contexts, what are the relationships between domains, instead of, okay, how am I going to store this? And what it actually does is that instead of being the architect and picking up your marker and drawing something nice on a whiteboard and then shipping that out as an artifact towards your development team, is that actually what you're doing is you're trying to think and trying to reason what's actually happening within your organization. Not about the structure of your system, but basically the behavior of your organization, the behavior of your system, and its origins. And if people actually did this before, then they will know what's happening on this picture. Who doesn't know what's happening on this picture? Who knows? The rest, I guess. Yeah. So a way to actually do this and to have a kind of collaborative effort in trying to map out your business, how your business works, is called event storming. And when I prepared this talk, I didn't really have the idea of pushing event storming into this presentation. But eventually, if you want to do events first microservices, then you have to think in events. So this is basically also the direction we're going to take. So let's model a part in the e-commerce system, and let's just start somewhere and say, okay, we have an event within your organization, and that's called order created. So if somebody just puts this orange sticky on a very big wall of paper, then at some point other people will start adding stickies, say, okay, there should be something which happening before this or should be happening after this, and eventually maybe we can describe a business flow. Oh, I'm using my phone, doesn't work that well. Something like this. So at some point we have an order created that will result in an order confirmed, then an order paid, picked, shipped, delivered. Kind of business flow. We're not talking about structure here, we're just talking about the way a business works. And if you look at the word order, order created, well, it could potentially be somebody who's just ordering something. Order paid is still the order being paid, so I think that should still relate towards the created. But once we're actually in the shipped and delivered, that means that we're actually adding potential information there, which changes the meaning of order there. If you're in your organization and somebody checks if an order has been paid and then just gives it to the delivery guy, then if you talk with the delivery guy and say, okay, what is order for you? Well, then it's not something somebody paid, it's something he should have shipped or should be shipped. So I'm actually taking a bit of a leap here and say, okay, maybe we have recognized, and normally you get a bit of, you have a longer process to actually see if there's a bounded context here. But let's just assume that we've seen that this happened and we said, okay, within that part, we could say, okay, we have a bounded context which we call order. And on the other hand, there's something different happening there. It's potentially a different order, but we call it shipment domain here. And let's just model that out in code, because eventually we want to have something actually working in code, right? So I just opened a trait called order events, and I implemented an order created, an order confirmed, and an order paid, and then some JSON formats to ensure we actually can send these events over the wire. And what I'm doing here, and potentially we could have named them differently, but I just wanted to show here that it's possible, is that within another package called shipping API, I will also define those orders. And it's potentially that those orders will eventually have a different state. They're actually also described differently here. But then we have the order picked, order shipped, and order delivered. So far, so good. But now we have just implemented those interfaces, and we should have some kind of framework in which we're actually going to send those events and actually do something with those events. So that's where Lagom comes in. And Lagom is a Swedish word meaning just right, fitting neither too much nor too little. I don't think anybody has anything on this meaning, but I think it's better to maybe describe it like this, is that Lagom provides an opinionated way of building microservices that intentionally constrains what the developer can do and how they should do it. I do not actually know if this was in the documentation, but I guess I picked it up somewhere. And for me, it was basically the main reason why I first looked into Lagom. and said, this is not a very good idea. I don't know what you're doing, Lightbend. I know you're currently building it for Java, but is it really the way we should go to? And that's mostly because I like Akka and I like the internals, and I want to basically play with the internals. But if you look at an organization which just wants to deliver business value, wants to deliver actually wants to do their business driven by technology, they're not interested in internals, they just want to fix their software. And I think having constraints there will help. But that's something for a different talk. So using Lagom, what we can do is within the same API package that we can state, okay, then we have the order service. And within that order service, we're going to expose a topic of order events of type order event. And I'm binding that here towards the topic. And eventually, maybe that can end up in Kafka, or if you want to use Kinesis or whatever, it's just a message broker. So the implementation doesn't really matter that much. So what we have now is an interface, no implementation yet, in which we say, okay, if somebody imports this API package, he can see that, well, basically I have an order service. And within that order service, there's a topic which is exposing order events. So we just described this context, two bounded contexts, and we have the order paid and the order picked. Those are basically cause and effect. The problem is that we don't have any mechanics currently to actually show how these things will interact and how that cause and effect will work. And this is where normally in the event storming session, people will say, okay, we don't have everything to actually model this, so then we'll introduce new sticky, the purple one, or the pink one, and that's a policy. So what we can do with the policy is that, okay, whenever something happens, then do this. So what you could say is that between the order paid and the whenever and the order picked, we could say, okay, whenever an order is paid, then eventually go to the right and do your thing. And we can model this by using a topic subscriber in Lagom. And what we have here is that we have an order service subscriber with the order service. We just import a package. The order service doesn't really have to know that we're importing that. So in that case, we're completely autonomous by just consuming that however we like. And then when we receive the order paid, we should do something. And like in this slide here, if you have an order paid, and then whenever an order is paid, an order picked, it's nice that we have this policy, but nothing is happening yet. And that's also what you see here. So actually what we need is an additional sticky, the blue one, and that's one of the commands. So what we can say is that at some point, somebody will send a command at payment information. That will result in an order being paid. So whenever an order is paid, then somebody should pick this order, and that order will be picked. And I think this is the point in which we actually describe the way our business is working, but we're still missing one thing. So going back, do not start from a structure, but maybe start from events. At this point, we maybe need structure, because there should be some point here between the at payment information and the order paid. There should be something emitting those events and actually taking those commands. And in domain-driven design, we have a term for that. It's an aggregate. So an aggregate in this case takes the commands and eventually emits events. So clear so far? Okay. So how can we model this? Well, if you look at this image and you're a bit familiar with Akka, is that this came from a presentation I did about actors, and it's still the same image. So if people talk about domain-driven design and how that how that model of aggregates will fit on an actor, is basically can use the same image to describe both. So for me, it's also it's a one-on-one. So within Lagom, also the aggregates are powered by an actor. And what you can do there is you say, okay, I will just send a command which does a create order, does potentially something towards its internal state, and eventually sends an event out. And we want to have a reply to ensure that we actually receive that command. But I said something now which isn't completely accurate, because I said he will do something towards his state and emit an event. If you've not used Lagom, but you've used Akka persistence, you know that eventually state changes aren't directly made. It's basically taking a command, emitting an event, and then eventually taking those events back and updating your state from there. And this pattern is called event sourcing. So if you used event sourcing before, I think this would be familiar. If you haven't, but you're familiar with functional programming languages, is that if you look at the current state, it's basically a fold left on every event you've seen before, and that eventually will be your state. So if you look at the order domain we had here from a other perspective, and not from the event sourcing perspective, event storming perspective, sorry, is that you just can describe the order domain as something which will just have a set of entities embedded within its domain. And just to make a jump into the internal infrastructure there, is all of those aggregates are actually powered by Akka cluster internally. And it's actually quite nice because if you look from a stateful perspective, and a lot of the problems you normally see with microservices is in scaling states, is that you already get this for free. Within Akka cluster, you can just state, okay, we have multiple machines in a cluster. Those could be just like, I have my order service and I have my entities there, and eventually I'm just going to place 3 machines there. And using a sharding algorithm, like for instance hashing the ID of the orders, I can say, okay, somewhere in this address space my aggregates will end up, and then I also know where eventually those aggregates will end up on the machines. So the power of this is that actually, I was just sidestepping here in the more technical parts of Akka, but if you use Lagom, this is all managed out of the box. So if you just have a service, if they can connect to each other, they will form a cluster. You can just spawn aggregates, that will work. If you send commands, then aggregates will automatically boot up. They will passivate to ensure that your memory won't be completely overthrown or overflown when you get a lot of commands in. And if he just wants to resume on the next command, he can basically resume from memory if it's still active, or from disk by using the event sourcing pattern. So it's a good opinion in this case, I guess. So going back to the code, we want to handle those commands. What we can do here is to additionally create a commands. We call the p-order command. We have a create order, and add payments, and then get order. Some people will now question me, why have you have a p prefixed on the order here? And I think it's better to actually describe that in the for the events, is if you have the API package in which you're basically exposing what kind of events you want to share potentially to other servers or other subscribers, you want to separate those from your internal events. Because your life cycle of your API will always be different than your life cycle of potentially your internal events. And that's also actually the thing we want to do. If we were talking about bounded context, we actually want to limit the complexity leaking out of our domain. So whatever we're doing here shouldn't be the same things as the things we're doing outside. So we have a trait p-order event, which extends an aggregate event. Not that much of importance, but we need it later. And then we have an order created, an order confirmed, and an order paid event. And let's say that we have a state called p-order, which also have shipping information, SKU, and an order line. Is this readable, by the way? Not too small? Yeah. So if you actually use Akka persistence or use actors before, this is, I think, would be a bit familiar if you look at the command and event handler. But there's one big difference, is that you can actually cannot touch the internal state of that actor. So what you have is some dependent types here. Say, okay, this is the internal command I will have, the internal event and the state. So we have the order command, the order event, and initially, the order state. And we just pass it along an initial state. And what the opinionated approach in Lagom actually did here is to state, okay, the only changes you will have on your state while you're consuming an event is basically a functional transition from the type you already had. And doing these state transitions, you can actually also do one other thing, which I didn't describe here, but you can also change the behavior of your actor. So this is basically the context.become and unbecome you have with the Akka actors, but now it's abstracted away a bit differently. And what you see here is that we take 2 commands, the create order command and the add payment command, and a read only command and get order. And what we do is when we get the create order command in, we persist the event, and then we just reply done. So we're not changing any state here. This is basically just emitting an event or storing that event. And eventually we have the add payment command, which is also storing the order paid command and also an order confirmed command. So we're emitting 2 events here, spawning out of that single command. And if we just read in the bottom, we have the on event, which is another event handler, which is pattern matching on the events which we are emitting. And that has an order created, an order paid, and an order confirmed. And there we're actually changing the state. So this is basically the normal event sourcing pattern. And in this case, it really doesn't matter if those events are created by some new command coming in or just the aggregates resuming from disk. So what we wanted to do is, okay, now we have something in which we can send commands. Then we had the aggregates, and then we had the events coming out. But we want to share this. I mean, that's basically the thing. We want to basically gap or bridge the gap and say, okay, how can we go from a order confirmed to an order picked? And I hope this is also readable. Too much code on the slides. So what we can do here is we have a service implementation, which is basically the implementation of the API definition I had before. Sorry? I don't think it's not readable. This at the back. Okay. Let me see if I can enlarge it.
I think what can be hard, but maybe it's too late, is the contrast, because it's a dark screen.
Yeah.
It's on the slide, it would be hard to change it.
Yeah, if the lights can dim completely. This is better? Do I also have to go to the previous slide to, or was that clear? I can just, yeah, I think this is better. No, never mind. Too far back. Too far back. Yeah, so this is the entity. So if you couldn't read it before, the command handler, the event handler. And what we do here, and I hope it's now readable. Still too small? Okay. So at first we have a service call. I'm not going to go into that there, but besides just exposing a topic from service definition, you can also expose something which can eventually be implemented by a simple REST call. And what we have there is the confirm order commands, your service call, which eventually will ask the persistent entity registry. So that's basically the repository, if you're talking about domain-driven design patterns. And within that repository, we can state, okay, we want to have an entity of type order entity, and we just want to have the order entity back with the identifier of the order ID. And then we just ask a command, sending a command to say, okay, add payments. And like I described before, there's no actor systems here, nothing about actor reference or whatever. Basically, that's completely abstracted away in the repository pattern. And what we can do there is, additionally, we can implement the topic. And what we have here is that we state, okay, get an event stream back from the repository. So that means that for the type of order events, so that's a tag, we just want to have all of the events happening within your system. And what you can do there is just to filter, say, okay, we just want to have the order created and order paid events. You just want to emit those. And once we get the internal persistent order event for the order created, we will mutate that back towards the API implementation we had of that order. So actually decoupling there, and eventually sending that message back. And if we have the order paid, we basically do the same, but we just need some additional information. So we're asking currently the aggregate for additional information and merging that in towards our event which we're exposing. One thing to note here, by the way, is the offset. Internally within the repository, every event eventually stored will get a sequence number. And the only way to actually ensure that you're completely writing your events in a durable manner, a durable fashion towards your message broker, is to synchronize the offset you have internally and the offset you have on your message broker. So at some point your message broker goes down, but your application or service is still up. That doesn't really matter. The only issue you have there is that potentially you have a consistency issue, because if your message broker went down for an hour, and you have, received 200 events in an hour, and your message broker comes up again, then you're basically pushing then all of those events on your message broker. So eventually maybe any side effects which will happen then on the other service will be delayed. So what we do now is we basically model this kind of behavior. Then we say, okay, we have an order service which will emit an order paid event. We can just push it on a message broker. And the shipment service, we really don't care from an order domain perspective if the thing actually exists, but he can just pick up the events and say, okay, internally we have that policy and we will send the ship order command. And this would be the implementation. So we first had the non-implemented question marks, but now what we can do internally is say, okay, somewhere within our shipping service, we will have a subscriber which will give the persistent entity registry of that service and the basically the connection towards the order service. And at every single time an order paid event comes in, we can just ask the the entity reference for that specific order ID, because we're going to couple there. So eventually the order ID in the shipment service and the order ID in the order service will be the same. And then we can just say ship order. One also important thing to note here is the map async there, and the fact that I'm, for all of the other things, returning a future.successful done. I've seen implementations at a customer doing Lagom and having a try catch statement there, and if something fails, he just, basically did a done and said, okay, not my problem anymore. But in the same manner as we had the offset spooling towards the message broker, underneath this at least once function is actually using the Kafka, at least for the message broker implementation for Kafka, is using the Akka streams consumer with the committable offset functionality. So that means that at every single future going in which returns successful, he will automatically send the new offset towards Kafka. So if you're just try catching there and sending done backs, that basically means that you're spooling your offset on the message broker and eventually just using messages which you can actually very hard to get back. If you fail here, because the entity the aggregate is down or your database is down or whatever, that means that you're not spooling your offset. So if you have a problem in your system, you're deploying that, and this part goes down or this part fails, it doesn't really matter that much. Because if you fix it and redeploy it again, you will just consume all of the events currently still on the message broker. So in a way, you're actually sacrificing consistency. Because normally if you have, for instance, a situation in which you say, okay, if an order has been paid, I want to immediately know if the shipment service will eventually ship that thing. But if you look in an organization, that's almost never the case. So somebody says, okay, please ship these things. And if it takes 1 or 2 days, really care that much. And in this way, we're sacrificing consistency, but we have a level of durability by using those offsets. So what we can actually do, instead of having a very commanding behavior between services, which can result in some kind of microlith, in which we have the feeling that we're implementing microservices, but because the connections between the services is that hard and that strict, is that if one service goes down, everything goes down, is that we're actually, by just doing policies for behavior, we just reach autonomy. Because the order service can just do its thing. If the shipment service just does a thing and the order service goes down, you will eventually just not get any new orders. But that generally doesn't matter that much. And I think one of the important parts is going back towards the structure first domain-driven design is that as long as the events are readable on the topic, the origin is of less importance. So that means that as long as we're exposing our events on the same topic, it doesn't really matter what service is emitting that. True, we maybe have to subscribe towards another API package, but it's a very small change. So if you're just focusing on the events first approach, instead of containing all of your state locally in one machine, is that at some point if you say, okay, we just had the bounded context wrong, we have to combine the order and the shipment service together again, or maybe split up the order service, it's actually quite easy to do that. So, at least for me, I think an events-first approach delivers on a better way of modeling business and technology. Something dropped out of my slide, I guess. While getting a more resilient and a more elastic system, basically for free. I'm out of slides. Any questions? No? Sorry?
If your server crashes, what
yeah.
happens with the order inside this service?
The order inside your service, if your service crashes, what happens with that order? Well, if you just have, I mean, if you took the order and wrote it down into your events log or whatever, so you actually got the command and you basically persisted it, then if your service comes up again, then you can just resume it. And if the offset between your local event log and your event log on your message broker is different, then he will just resync them. So that won't be an issue. Any other questions? No? Well, thank you for your time.